Okay, so this lesson is from the 6th day of Unit 2. So today we started a new topic. We learned about what are called matrices. So if I'm talking about one matrix, it's called a matrix if we're talking about just one of them. And if we're talking about several, they are the plural of matrix is matrices. So if I'm looking at this right here, this is called a matrix. If I'm looking at all three of them, they're matrices. So in your notes, go ahead and copy those three matrices. Okay. So the first thing that we did is I just described some or gave some basic information about matrices. So first of all, matrices generally involve a lot of numbers. They're not usually this small. Applications for matrices are generally in business when you're needing to do operations with a bunch of numbers at once, like hundreds or thousands of numbers to figure out like profits or costs or things like that. Well, matrices allow you to do those operations with several numbers, hundreds or thousands of numbers, very quickly all at once. So that's the reason for matrices. So again, these matrices are small. They only contain a few numbers each, but generally matrices are used when you have a lot of numbers. So the first thing we talked about is that when you're naming a matrix, it gets named by using a capital letter. So you can see we have matrix A, B, and C. Now, also, when you are reading a matrix, we read matrices just like we read from left to right and top to bottom. So this matrix A is 1, 2, 3, 4, 5, 6. Matrix B, 1, 3, negative 2. And matrix C, 7, negative 2, 3, 4, negative 5, 8. Okay, now, as I was reading those off, I was actually reading across what are called the rows. Rows run across left to right. On the other hand, we also have vertical up and down. Those are called columns. Okay, so we have rows and columns. When we're looking at matrices, we have to talk about what are called dimensions. Dimensions mean I'm going to list the number of rows first by, in other words, I put the X there, meaning by the number of columns second. So if I'm listing the dimensions for this matrix here, matrix A, it has 2 rows and 3 columns, which means that this is a 2 by 3 matrix, or a matrix with dimensions 2 by 3. So go ahead and figure out the dimensions for matrix B and matrix C. So B is 3 by 1 and C is 2 by 3. Okay. Next, we talked about not only do matrices have dimensions, but we can look at a specific spot in a matrix. So let's say I'm talking about this number 3, for instance. Number 3 is in a specific spot in that matrix, and when we're labeling that spot or position, first of all, we use the letter that the matrix was named. So capital A represents the matrix itself. If I use a lowercase a, that means I'm referring to an entry in the matrix. So lowercase a, and then we're going to write a subscript here, and subscript meaning lower, smaller. And we'll put the row number first and the column number second. So A1, 3, and again that 1, 3 is a subscript. A1, 3 means the entry in matrix A in the first row, third column, which is equal to 3. Okay, so what if I ask you to give me the placement of the 4? Well, that's in the second row, first column. So that would be A2, 1. That's equal to 4. Okay, so go ahead and label the placement here. So that's matrix B, so I'm going to use a lowercase b, and it's in the second row, first column. So B2, 1 is equal to 3. Okay. Lastly, if I ask you find C2, 2, 3. You would go to matrix C, you would go to the second row, third column, that's 8. C2, 3 is equal to 8. Okay, so that's dealing with dimensions and positions in a matrix. The next thing that we need to look at or talk about is adding matrices and subtracting. So adding and subtracting matrices. First of all, the matrices must have the same dimensions in order to add or subtract. So if I ask you to find A plus B, well, we already said 2 by 3 and 3 by 1, they're not the same. So because they're not the exact same dimensions, then I would say not possible. It's not possible for me to add matrices or subtract matrices when the dimensions are not the same. On the other hand, though, if I asked for A plus C, well, that's a 2 by 3 and a 2 by 3. So that is possible. So when it is possible, you add or subtract the numbers in the corresponding positions. So I'm going to get a 2 by 3 because A and C are both 2 by 3s. So I'm going to get a 2 by 3. And then I'm just going to go in order and add. So 1 plus 7, they're both in the 1, 1 spot. 1 plus 7 is 8. And then the 1, 2 spot is 2 plus negative 2, which is 0. And then the 1, 3 spot, 3 plus 3 is 6. 4 plus 4 is 8. 5 plus negative 5 is 0. And 6 plus 8 is 14. So that's A plus C. A minus C, same idea. I'm going to get, again, a 2 by 3, but this time I'm going to subtract. So 1 minus 7 is negative 6. 2 minus negative 2. 2 minus negative 2 is 2 plus 2, which is 4. 3 minus 3 is 0. 4 minus 4 is 0. 5 minus negative 5 is 5 plus 5, which is 10. And 6 minus 8 gives me negative 2. So that's A minus C. Okay. Next, let's find A plus A. So A plus A, they're the same dimensions, so I can add them, and then I'm just adding 1 plus 1, 2 plus 2, 3 plus 3, 4 plus 4, 5 plus 5, and 6 plus 6. Okay. Now, the reason I had to do that one was because I wanted you to see that A plus A is the same thing as if I were to say 2A, 2 times matrix A. So we can write it that way, 2 times matrix A. Well, 2 times 1, 2, 3, 4, 5, 6 was our matrix A. And when we write that 2 times a matrix, when we have a number out front, we do exactly like what you can see is happening here. We multiply that number times every number inside the matrix. So when I multiply that 2 times 1, 2, 3, 4, 5, 6, I get 2, 4, 6, 8, 10. 10, I don't know why it stopped writing, but let's 10 and 12. Okay, so that number, when we have a number out front of a matrix, you want to put this in your notes, that has a name, it's called a scalar. A scalar. And all that means is that you'll take that number times all of the numbers inside the matrix. Okay. All right, next. So go ahead and copy that into your notes. So to do this problem, what we have to realize is that matrices follow order of operations just like normal numbers or expressions do. meaning that I'm going to start with parentheses first. So I'm going to copy the 5 here in the parentheses. I'm going to go ahead and multiply that scalar times the matrix. So when I do that, I'm getting 3, 6, 9, 12, 15, and 18. Here, I'm going to change this to plus and negative and distribute the negative. I just think it's a little bit easier than subtracting. So I'm going to add then my next matrix, which is -2 times 7, -14, -2 times -2, +4, -2 times 3 is -6, -2 times 4, -8, -2 times -5, +10, and -2 times 8, -16. So now that I've multiplied the scalars, now I can go ahead and finish the parentheses, which means add those two matrices. So I can add them because I do have the same dimensions. So 3 plus -14 is -11, 6 plus 4 is 10, 9 plus -6 is 3, 12 plus -8 is 4, 15 plus 10 is 25, and 18 plus -16 is 2. So I have a scalar left times a matrix. So I'm going to just go ahead and distribute. So I'm getting -55, 50, 15, 20, 125, and 10. And that is my final answer. Okay, so the point is that matrices follow order of operations as well. Now, I just want to point out one other thing here in this problem. If you wanted to back up here at this step, you could have distributed the 5 and use it like a scalar and multiplied the 5 by the first matrix and the 5 by the second matrix, and then added the two matrices. That's fine. So in other words, because matrices follow order of operations, they also follow all of the rules of math, which we know that's really just the distributive property there. So matrices follow the distributive property as well. Okay, but just as easy to do it the way we did also. Okay. Now, sometimes matrices involve variables. So go ahead and copy these two. Okay, so the first one, we just have a scalar in the front times a 1 by 3 matrix, which just means I'm going to multiply that scalar times all the numbers. So I'm still going to get a 1 by 3, and I'm just going to multiply -5b times 8r gives me -40br. -5b times 3x squared gives me -15bx squared. And last, -5b times 2b gives us -10b squared. Okay, which is our answer. So again, I just wanted to point out that sometimes you can have variables. The process is still the same now. Next one. So this time we have an addition sign, which means the dimensions have to be the same, which they are. I can see I have a 2 by 1 and a 2 by 1. So I'm going to go ahead and add them by making it a 2 by 1. Now when I go to add the -3r to the 6m, I see they're not like terms, so I just write -3r plus 6m. And I'm going to add the 2b plus the -8b, which gives me -6b because I can combine like terms there. Nothing else to do. That is my final answer. Okay. Okay, so tonight's homework is pages 17 and 18 in your Unit 2 packet. Okay, so do those problems for tomorrow.